Happy homecoming week. Today is Western Wednesday. I've got my horse. So we are going to be talking about proving segments and angles today. So the lesson is called Now I'm Convinced. So here's 6-1, justifying statements. So we have two learning goals today. We are going to be using definitions, properties, postulates, and theorems to justify statements. Okay, so properties we've learned, addition, property of equality, angle addition postulate, things like that. And then we're going to write two-column proofs to prove theorems about lines and angles. So we've seen two-column proofs where we have the statements and the reasonings when we solved equations, and now we're going to apply it to geometry today. So a proof is going to be an argument or a justification or a reason that something is true. Okay, lawyers argue about why things are true. They justify why so-and-so should pay them or go to jail, etc. But a proof is going to be an answer to the question, why? When the person asking wants, a proof is an answer to the question, why, when the person asking wants an argument that is indisputable. So indisputable means you can't argue with it. Their reasoning is perfect. So there are three basic requirements for constructing a good proof. So one, you have to be aware, and you have to have awareness and knowledge of the definitions of the terms related to what you are trying to prove. So if we're talking about segments, we need awareness about the segment addition postulate and midpoint. If we're talking about angles, I need some knowledge of my angles. So maybe complementary angles are going to come back, supplementary, etc. You need knowledge and understanding of postulates and previously proven theorems related to what you are trying to prove. Okay, so again, the angle addition postulate, segment addition postulate, I need understanding of those part plus part equals my whole. And then I need to know the basic rules of logic. So how do I sequence something in order logically to prove something? Okay? I can't take myself seriously. Okay. So, that's my phone. I'll be back. Okay, so to write a proof, you must be able to justify statements. Justify means write. So the statement in example A are based on the diagram to the right, in which lines AC and EG and DF, all intersect, they cross at point B. Each of the following statements is justified using a property, a postulate, or a definition. So let's take a look at these problems. So an example of a statement. We notice that statements have all the math terms. So they have angle symbols, they have equal signs, they have degrees, they have congruent symbols. So a statement is all the mathy terminology. The justifications are the properties, the definitions, the postulates, etc. So let's take a look at this first one. It says ABE is a right angle. So ABE is a right angle. So I can go ahead and write that box. So if ABE is a right angle, then I know that the measure, that's the little M stands for, of ABE is 90. Okay? So if something is a right angle, I know it's 90 degrees. The justification of that, well, that's the definition of what a right angle is. Okay? So again, these are just kind of examples that we're going to look through. B says if 2 is congruent to 1, congruent means equal. So if 2 is congruent to 1, I'm going to make these angle marks, and then 1 is congruent to 5, then I know that 2 has to be congruent to 5. This is called the transitive property back to algebra. So I'm going to kind of do some things. If 2 is congruent to 1 and 1 is congruent to 5, then 2 is congruent to 5. So these 1s in the middle kind of cancel each other out, leaving you with 2 and 5. How this works with football. If Tennessee beats Florida and Florida beats Bama, then Tennessee should beat Bama. But transitive property doesn't work in football, and we can't beat Bama. But, yeah. So that's a transitive property. C says, given that B is the midpoint of AC, I can prove that AB is congruent to BC. So what that means, B is the midpoint, so B is the middle of A and C. Okay, if I go back to midpoint, I know midpoint's in the middle. It allowed me to make these tick marks earlier, so I know that they're congruent. So I know that if B is the middle, I know that each part, AB, has to be equal or congruent to BC. So the reasoning of that is that's the definition of what a midpoint is. Okay? All right, D says, I'm going to erase my picture up here. Goodbye. So D says, if the measure of angle 1, angle 2, plus the measure of ABE, that will equal the measure of DBE. So let's take a look at this. Angle 2 is over here in red. ABE is over here in green. If I add those two angles together, I should get the total of DBE, which I do in blue. So the red angle plus the green angle equals the blue angle, which that goes back to the angle addition postulate that we covered. Hence, they're adding angles. Okay. Next but not least, if angle 1 is supplementary to FBG, then I know that angle 1 plus the angle FBG have to equal 180. And so again, that's just our definition. We know supplementary means 180. That's the definition of a supplementary angle. Okay? So these are just some example statements and an example justification. Notice the vocabulary words are the same. So this says right angle over here. This says right angle over here. Midpoint over here. Midpoint over here. Adding angles. Adding angles. Supplementary. Supplementary. So they kind of have some similarities. Okay? All right. Time for y'all to try. Just kidding. Let's read this math tip. The reflexive and the symmetric and transitive properties apply to congruence as well as equality. So we talked about the reflexive property, flexing on both sides, same on both sides. Symmetric was when it was a mirror image, and we covered the transitive property. Those were true in algebra. They're true in geometry. All right, you're going to try A. So it wants you to only write the justification. So maybe definition of something, something bisector, vocab words, okay? So it's okay if you don't get it perfect, but see if you can guess some vocabulary words for A, B, C, D, and E. So press pause, and we'll go over our answers. I've been squatting this entire time. My legs hurt. Okay. So here are our answers. The first one was a segment addition postulate. So notice EB, we write line segments with 2 letters. So maybe we didn't put angle addition postulate because there wasn't an angle symbol. So that would be the angle addition postulate. I added this part plus this part to equal my total. Part B said if 5 was congruent to 6, then BF bisects EBC. So the word bisect, that's a definition of a bisector, and it's an angle bisector because I'm dealing with an angle. So it says if 5 is congruent to 6, then I know that this blue line is going to have this whole angle. So that's what an angle bisector does. C said if 1 plus 6 was 90, then I know they're complementary. So that's the definition of a complementary angle. D was probably tricky for y'all. So it says the measure of 1 plus the measure of 5 equals the measure of 6 plus the measure of 5. Then I know that the measure of 1 is equal to the measure of 6. Now it's kind of tricky, and I'm going to draw a picture for y'all. So I'm going to write out to the side. So angle 1 plus angle 5 equals angle 6 plus angle 5. And then they got to angle 1 equals angle 6. I took out the little m's. So basically you have to ask yourself what happened from this step to this step, and the 5s completely went away. How you can get the 5s to go away is to subtract the angle 5s from both sides. Boom, boom, leaving you with the angle 1 equals angle 6. So since they subtracted on both sides, that'd be the subtraction property of equality. That one was tricky. E was probably tricky too. Maybe you forgot what this cool symbol means. So the upside down T is perpendicular. Okay, perpendicular is when lines cross and you get 90-degree angles all around. So boom, 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 boom. Okay, so if 2 lines are perpendicular, then I know a right angle was formed. That is going to be the definition of perpendicular lines. So if you see this perpendicular symbol, the upside down T, that is probably going to be definition of perpendicular lines. Okay, so hopefully you got A, B, and C correct. D and E were a little bit trickier. But again, this stuff is brand new and it takes practice. So we just got to work on it. All right. Let me know if you have any questions. Otherwise, I want you to try 1, 2, and 3. Check your understanding. And then we'll go over them. So let's read this math tip. It says, do not assume that an angle is right just because it looks to measure 90. You can only conclude or know that an angle is right if you are given information or if it has a little box symbol, like over here, or that we have proved it as a right angle. So what that's saying is, for example, if you see this beautiful angle, you cannot assume it looks right because Miss Callahan drew an awesome angle. If it doesn't have numbers, so if it was like 40 and 50, then I know it's the right angle because they add up to 90, or it has to have a box. But you cannot assume it's 90 just because it looks it. All right, try 1, 2, and 3, press pause, and we'll go over our answers. Press pause. Number 1 says, explain why the following statement does not need to be justified. Why don't I have to prove it? So the midpoint of a segment is a point on the segment that divides it into 2 congruent parts. The reason I don't have to prove that is that's the definition of it. So if that is the definition, you don't need to prove it. We assume that it's true because that's the definition. Number 2 says, given that RS and ST share the endpoint S, critique the reasoning of others. Based on the information, Michelle says that the segment addition postulate justifies that RS plus ST equals RT. Is there a flaw in her reasoning, or is she correct? So, I bet all of y'all thought this. They share an endpoint, so we have R and S and T. I guess that's what y'all thought. And if you thought that way, you would say, yeah, she's right. RS, this part, plus the other part, equals the whole thing. However, there is a flaw, because she did not say that S was in between it. Okay? In the segment addition postulate, it told us that S was in between it, aka on the same line. Then it was true. But we could have also drawn this cool picture looking like a right angle. RS and ST, they both share an endpoint, but they're not in the same line. Okay, so the flaw in her reasoning is she didn't say that they were on the same line, so she didn't know point S was in between it, therefore I can't prove the segment addition postulate. If she said that RS and ST shared an endpoint and they were on the same line, or that S was in between it, then she could totally prove that. That one was tricky. Turn my phone. Bum-ba-da-bum. Last but not least, write and justify 2 statements based on the figure. So there are lots of answers, and here's an sample one. So a sample one would be angle GFJ. So this angle measures 90, so equals 90, and the reasoning would be that's the definition of a right angle. Okay, that's one example. Another example you could have said was the angle addition postulate. So I could have said this first angle, so angle GFH, plus the measure of the other part, HFJ, the green one. That'll add up to my blue one of HFJ. No, boom, GFH. There it goes. They wrote a little bit backwards. I'm going to write it forwards. So angle GFH plus angle HFJ will equal the total of GFJ. Either way. You could have probably said something about complementary angles too. So you could have said that GFH. Hi, you're in my video. Or you could have said that HFJ, those 2 angles equal 90 because they're complementary. That would be a good one too. Okay, so if you want to check your answers, let me know. But it just wanted a statement and a justification. All right, last but not least, you're going to try 6-1-1 practice. So try 4 through 9. It just wants you to write a definition, a postulate, or a property. So they gave you all the math terminology, and it just wants you to write the definition or the justification. And then 9 is a little different. Okay? So try those, press pause, and we'll go over our answers. All right, so the answer to number 4 was the definition of supplementary angles. Keyword in there was supplementary, so it's going to be definition of supplementary. Number 2 had the keyword of bisect, and I had an angle, so it's probably the definition of an angle bisector. C was adding 2 letters, which is a segment, so that would probably be the segment addition postulate. Number 7 had this upside down T, which we know means perpendicular, so that is why it's the definition of perpendicular lines. And then 8 might have been tricky, but again, 3 is congruent to 6. Hold on. addition property of equality. I'm going to write that out so we can see it. So angle 3 equals angle 6 is the first line. Then it says angle 3 plus angle 2 equals angle 6 plus angle 2. So it helps you write it out if you write it kind of step by step. So I went from this green line to this green line. What changed was they added the angle 2 to both sides, so that is why it is the addition property of equality. So that one could have been tricky because it was all jumbled up. All right, last but not least, write a statement related to the figure above that can be justified using the angle addition postulate. There are so many answers to this one, so I'm just going to share one out, and if you want me to check yours, let me know. But it says the measure of EBD, so EBD is here, angle 1, so you could have even said angle 1. So EBD plus DBC, that angle plus that angle will equal the total, which is EBC. EBC. So you could have had literally a million answers. You could have said angle 3 plus angle 4 equals FBH. You could have said angle 6 plus angle 5 equals EBH. Literally tons of answers as long as you add two angles together to equal the part. So if you have any questions, let me know. Otherwise, you just learned how to justify statements and write them. So let me know if you have any questions. Otherwise, you can get to practicing. See you later, cowboys and cowgirls. Oh, that was terrible.